Okay, settle in. I'll give you a minute or so to pull out your periodic tables. So get those. Actually, I'll give you less than a minute. Come on, let's go. Awkward silence. Although I'm sure it's not silent, you guys are probably talking. All right, we got those periodic tables out? I hope so. Yesterday, hopefully I went through this. I showed you how the periodic table is organized according to electron configuration. We had the two blocks here, the two columns here that were the S block. The S sublevel holds 2 electrons. Hey, there's 2 columns there, right? And the P sublevel holds 6 electrons, and we had 1, 2, 3, 4, 5, 6 columns. Keep in mind helium is part of the S block, which is why we threw that over there, because it's in the first row. It only gets 2 electrons maximum. We had the D block, held 10 electrons. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. And then lastly, we had the F block, and I'm not going to count them. We know there's 14 columns there. And then the rows across were the energy levels: first energy level, second energy level, third energy level, fourth energy level. However, because of some overlap, when you get to here, this jumps back to 3D and then back to 4P. 5S, 4D, okay? And then when we get down here, don't forget we got 6S, and then we jump down through 4F. Remember, this is 57 through 70 is all down here. The only reason it's down here is to make the periodic table fit onto one page. So to make that fit on one page so it's not all big and wide, we pull those columns down here. So we go 4F, and then we jump back to 5D. So after 70 comes 71, right? After 56 comes 57. So we go from 56 down to 57 and cut through all that, and then 70, then back here for 71, 72, and so on. So this is 5D, and then here we would go 7S, 4F, and then 6D. All right, so let's go ahead and take a look at a couple of examples. Let's go ahead and do a couple of examples. I'm going to put something up here. I want you to do it. I'll give you about a minute or so, and then I'm going to go ahead and show the answer. So let's take an example here. Let's do silicon. All right, silicon. So silicon, I'll even spot you where it's at. Silicon, right there. Grand total 14 electrons. So we got to make sure we get to 14 electrons. You guys are working on it, right? Writing down the electron configuration for silicon with 14 electrons. Really, Eunice? Really? All right, here we go. So I need to go from here. Yeah, I don't want that. I need to go from here all the way to here, silicon. So I start at, again, we always start the same way. I'm going to start at 1s. So it's 1s. And I'm going through the whole row, so that's 1s2. Remember, that goes up as a superscript. So this first number is my energy level. The letter is the sublevel, and that's the number of electrons in that sublevel. So here I am now, and I need to get here. I'm not there yet, so I go down to the second level, second row, second energy level, and I go 2s2, right? That takes me to beryllium. Still not at silicon, so I keep going across the row, and this will give me 2p6. 2p6 puts me at neon. Still not at silicon, so I go down to the third row, third energy level, and that's 3s2. 3s2. 3p. I'm in the second column, so it's 3p2. So that would be silicon. Okay, it always starts the same way. Alright, let's try another one. Let's try something like, I don't know, let's do something long. Let's do beryllium. Let me get rid of this here. I'd ask if there were questions, but I can't because, well, I'm not here to answer. So here we go with beryllium. Te down there, beryllium, Te, and beryllium. Let's get rid of this. We don't. Well, that's always going to be our starting point. Beryllium is way down here. So that's where I'm going to get down to. I'm starting up at helium. That's 52 electrons. Ready, go. Remember, it's like kind of like a grid system, you know, my energy levels and my sublevels. How we doing? And as always, we're going to start up at helium. And, here we go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is where I have to be careful. 4s2 takes me down to here, right? I just went through the first three rows. I know that I'm going all the way down to the fifth row down here. I'm going to end at 5p1, 2, 3, 4. So I'm going to keep going until I get to 5p4, and then I'm going to stop. That's my stopping point, 5p4. I'm in the fifth row. I'm in the p block, and I'm in the fourth column. So 5p4. So let's see here. 4s2, again, this is where I got to be careful because now I'm going to jump back to 3D. So it's 3d10 because I go all the way through that block, and then back to 4s, or I mean, excuse me, 4p. So that's 4p6. Still not there, so that's 5s2. 5s2. Again, I got to be careful. It's 4d10 because I'm going all the way through the block, and then I'm at 5p. So now I got to watch where I'm at. 5p1, 2, 3, 4. Now, just to be sure that we did this right, I should come up with 52 electrons. So what I'm going to do is I'm going to add up the superscripts. So it's 2 plus 2, that's 4, plus another 6 is 10, 10, 12, 18, 20, 30, 36, 38, 48, plus 4 is 52 electrons. Got it all covered. You might want to spot check them every once in a while. All right, this is a lot of writing, right? In the grand scheme of things, if I didn't tell you this yesterday, I'm going to tell you now. There's something out there called Noble Gas Shorthand. It's a shorter way to do this. Remember, these guys are called electron configurations. Electron configurations. They're different from boxes and arrows. I say boxes and arrows. You guys say... Come on, you should have said orbital diagram. Everyone knows that. Loud and proud. Let's try this again. I say boxes and arrows. You say, hopefully I got a response. If I say orbital diagrams, you say boxes and arrows. Right. All right. So, again, keep in mind there's going to be 3 ways to do these things. Boxes and arrows, electron configurations, and then the last way is noble gas shorthand. So let's go ahead and learn a little bit about noble gas shorthand here. I hope I've got enough room to do it here. I'm going to give it a go. I'm going to get rid of all this. And yeah, we'll give it a go. I think I can do this. Because I kind of need the periodic table here. Let's get rid of that. Let's get rid of that. And that should do it. All right. Let's write the electron configuration for neon. Right here. Ne, neon, 10 electrons. Ready, go. 1s2, 2s2, 2p6, and I'm done, right? There it is, 2p6. 1s2, all the way through the first row, 2s2, 2p6, and I'm there. Now let's go ahead right below it. Let's write the electron. You guys can do this in your notes somewhere, or maybe on the back of the note packet, I guess. No, I don't want to do neon. What am I doing? I just did neon. Let's do something like magnesium. So magnesium, again, they all start the same way. We've seen a lot of repetition here. So it's going to be 1s2, 2s2, 2p6, 3s2. That puts me right there on magnesium. So in noble gas shorthand, you'll notice neon right there, that guy is a noble gas. Anything in the last row here is a noble gas. Excuse me, last column here is a noble gas. So this is a noble gas. So what we do in noble gas shorthand is, instead of rewriting all of this again down here, notice it's the same. What we do is we say, okay, now playing the part of 1s2, 2s2, 2p6 is neon. So for noble gas shorthand, and it only works with noble gases. It's not like halogen shorthand. It's noble gas shorthand. So the only thing you can substitute in is noble gases. So anything from this column. So noble gas shorthand would be neon. Oh, wait a second here. So noble gas shorthand for magnesium would be neon, and then whatever follows. So I more or less say, okay, everything's the same up there. So then after neon would come 3s2, and I'm done. Much shorter, isn't it? You guys are probably asking, well, why didn't you just show us that way in the first place? Because this is a lot easier and a lot shorter. I could, but you wouldn't, until you get the periodic table trick, until you can see how to write the longhand version of the electron configurations, you really won't be able to write neon, or excuse me, noble gas shorthand, because it's hard to see. You got to kind of build to it. Now you're looking and go, well, okay, I still had to write these two things in order to get to the noble gas shorthand. You don't have to do that. Let me show you how you can do it without doing that. Get rid of this. Get rid of this. And let me do this. Let's pick something long that would be a pain to write, right? Let's do something like manganese right there. Okay, manganese. That's what we're going to do. We're going to do manganese. Mn. So here it is. Oops. Manganese. Mn. So what I'm going to do is, if I go over to this noble gas, that's too far. I've already passed manganese. That's no good. I want to go to the noble gas that is just before the element that I'm trying to write the electron configuration for. So I go backwards until I hit a noble gas. Chromium, no. Vanadium, no. Titanium, no. Scandium, no. Calcium, no. Potassium, no. Argon, bingo, got it. So that goes in here. Argon, let me put a little semicolon or colon there. Argon, and then I go back forward again until I get to manganese. So that's going to be 4s2. Jump back down to 3D. 3D, 1, 2, 3, 4, 5. 3D, 5. And I'm done. Easier, right? Let's do something that would be really challenging without noble gas shorthand. Let's do osmium down here. Osmium right there. Let's get rid of that. We're going to do osmium. We're off to see the Wizard of Osmium. No, that wasn't funny. Right, there it is. Osmium. So again, I'm going to go backwards until I hit a noble gas. Backwards. No, 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 no. This is all down here. Definitely not noble gases. No, no, no. There it is. Xenon, the Princess Warrior. So xenon is my noble gas that I'm going to go forward from. So for osmium, I would put in brackets xenon, and then I go forward from there. So it's 6s2 right there. And then, whoa, there's the slide. I got to go down the slide and catch 4F. I'm going all the way through that because I'm going to osmium over here. So I go all the way through that. So that's going to be 4F, 14. And then I jump back up, and it's 5D, 5D. And that's going to be 1, 2, 3, 4, 5, 6. 5D6. Now, just for kicks, let's count out the electrons and make sure this worked out right. Osmium should have 76 electrons in the big parade. Xenon accounts for 54 of them, so it's 54 plus, I got 2 plus 14 plus 6 is going to be equal to, let's see here, that's 20, 22, 26, 76. Bingo, got it. Questions? Just kidding, still can't answer them. Hopefully this is good, going good from yesterday. I'm going to go ahead and stop this. I'm going to let you guys practice on the homework at some point. But I still have one more thing to do, I believe.